Welcome back to Kamal Home Academy, Encounter with the Art and Science of Ceramics. In this session, we will discuss about refractories used in blast furnace, trough or runner. Refractories for blast furnace, trough, runner. In the blast furnace cast house, trough is very crucial and important because slag and molten metal runs through it. In the blast furnace cast house, is very crucial and important because slag and molten metal runs through it. It is located in between the tap hole and the skimmer block. It is located in between tap hole and skimmer block. Shown in the figure. On the basis of operational requirements, trough can be classified into three categories. On the basis of operational requirements, trough can be classified into three categories. Number one, cooling type trough. Cooling type trough. Here slope of the trough is 1 to 3%. Here, tool of molten metal is retained. Number two is semi-cooling type trough. Semi-cooling type trough. Here slope of the trough is 3 to 5%. Here, thin layer of hot metal is retained. Layer of molten metal is retained after tapping. And the third one is non-cooling type. Non-cooling type trough. Here slope is more than 5%. Here no metal is retained. Now generally for large blast furnaces, cooling type troughs are used, and for small furnaces, non-cooling type troughs are used. Generally, for large blast furnaces, that is large volumes. Cooling type tubes, are used, and for small furnaces, small glass furnaces, non-cooling type troughs are used. Now, as for refractories used in the trough, diamond mass as well as ultra-low cement castables are used. Ultra-low cement castables are used only when at least 2 tap holes are available. Minimum 2 tap holes are available. Only ultra-low cement castables for new generation monolithics can be used because it takes more time. The operation of trough with ultra-low cement castables or self-flow castables takes more time. So it is possible only when more than 2 tap holes are available. So in a small furnaces where only 1 tap hole is there, only diamond mass is possible because it takes less time. Operation trough with diamond mass takes less time. Output is more with ultra-low cement castable. Trough line with ultra-low cement castables. The refractories used in blast furnace troughs are 70% alumina, heavy mass, based on Al-3 silicon carbide and carbon with tar resin bonded. Ultra-low cement castables, 75% alumina, ultra-low cement castable. Cement castables. Also known as new generation monolithics. Based on L2O3 silicon carbide carbon. Either hydraulic bond or gel bonded. These 75% alumina, self-broadcastable. Based on L2O3 silicon carbide and carbon. This is either hydraulic or gel bonded. Hydraulic or gel bonded. Now these ultra-low cement castables or self-flow castables can be used only when at least 2 tap holes are available in the glass furnace, because it takes preparation of trough with ultra-low cement castables or self-flow castables takes more time. If there is only 1 tap hole, then ramming mass is preferred. Only ramming mass is possible because it takes less time. Preparation of trough with ramming mass takes less time. But life is more in case of ultra-low cement castables or self-flow castables used in the blast troughs. The lining pattern is shown in the figure. Properties of these refractories are given in the detailed characteristics of these ramming mass and ultra-low cement castables and self-flow castables are given in the here in the table. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.